Hello, explorer of cosmic mysteries. Imagine a place in the universe where six galaxies are intertwined in a cosmic dance so tightly that it seems that they are about to collide. This is not science fiction or computer simulation. This is the reality we call Stephan's sextet, one of the most mysterious and visually fascinating objects in the observable cosmos. In 1877, French astronomer Edouard Stephan pointed his telescope at the constellation Pegasus and discovered something incredible. A compact group of galaxies so close to each other that they fit in the same field of view. What he saw challenged all notions of cosmic proportions. But here's a paradox that puzzles astronomers so far. Although the group is called a sextet, six, only five galaxies actually participate in the gravitational interaction. The sixth is a cosmic deceiver, an imposter galaxy that just happened to be in the same patch of the sky, being 7 times closer to us in reality. A visual illusion of cosmic proportions. The 5 true members of the group are about 290 million light years from Earth and are moving at incredible speeds, about 1,000 kilometers per second relative to each other. They literally tear each other apart by gravitational forces, pulling out long tails of stars and gas, creating shock waves where new stars are born at speeds of millions of solar masses. What makes Stephan's sextet a real space laboratory is the fact that we are witnessing a galactic catastrophe in slow motion here is a process that lasts hundreds of millions of years. But on a cosmic scale, it is the blink of an eye. When galaxies collide, something counterintuitive happens. The stars themselves almost never collide with each other. The distances between them are so vast that 2 galaxies can pass through each other like 2 scattered clouds of fireflies. But gas and dust are a completely different story. They collide with a monstrous force, heating up to millions of degrees, creating giant clouds of red-hot plasma that glow in X-rays. The James Webb Telescope recently took the most detailed images of the Stephan sextet in history, and what it found rewrote our understanding of this system. Infrared light revealed structures that had previously been hidden. Huge tidal tails stretching for hundreds of thousands of light years. Regions of explosive star formation where billions of new stars are born in a matter of millions of years, and streams of gas moving at speeds comparable to the speed of light. But the most intriguing detail is what astronomers call the intergalactic medium. Between galaxies stretch ghostly bridges of stars and gas. Stars that have been literally ripped from their home galaxies by gravitational forces and are now drifting in the intergalactic void. These exiled stars do not belong to any galaxy. They are space orphans, witnesses to a galactic drama. And here arises a question that haunts scientists. What will happen to this system in a billion years? Computer simulations show a fascinating and at the same time frightening picture. 5 galaxies of Stephan's sextet are doomed to merge. They perform their last dance before turning into one giant elliptical galaxy, a cosmic monster that will consume all its components. But this process is not a peaceful unification. This is a cosmic cataclysm of unimaginable proportions. The supermassive black holes at the centers of each galaxy, each with a mass of millions or billions of suns, will spiral closer together, emitting gravitational waves that will ripple the very fabric of space-time. When they finally collide, there will be a release of energy comparable to the explosion of billions of supernovae at the same time. Of particular interest is the galaxy NGC 6027A, one of the most active galaxies in the group. At its center is a supermassive black hole that is actively devouring matter, creating powerful jets of matter ejected at almost the speed of light perpendicular to the plane of the galaxy. These jets stretch for tens of thousands of light years and heat the surrounding space to incredible temperatures. But in GC 6027d, the smallest galaxy in the group, is showing signs of tidal disruption. Gravitational forces from neighboring galaxies literally tear it apart. In a few 100 million years, only a long tail of stars will remain, stretched in orbit around the forming supergalaxy. Which makes this picture even more dramatic. It is that we are witnessing not just destruction, but also incredible creation. In the zones of collision of gas clouds, pressure and temperature reach critical values, triggering waves of intense star formation. Astronomers call this phenomenon starburst regions. More stars are born here in 1 million years than in a quiet galaxy like our Milky Way in 100 million years. These are space maternity hospitals operating in overload mode. But there's also a dark side to this process. Young, massive stars live for only a few million years and then explode as supernovae, ejecting heavy elements, carbon, oxygen, iron, the very elements that make you and me up into space. Stephan's sextet now has hundreds of such explosions every century, enriching the intergalactic environment with building blocks for future generations of stars and planets. One of the most mysterious features of the system is the huge shock wave detected by the Spitzer telescope. It stretches for 100,000 light years and is moving through intergalactic gas at a speed of about 1,000 kilometers per second. This wave was created by one of the galaxies that literally breaks through the dense cloud of gas left by previous collisions. Imagine a supersonic plane breaking the sound barrier, only on a scale where the plane is an entire galaxy with hundreds of billions of stars. The redshift of light from different galaxies in the group tells us another intriguing story. The story that these galaxies move not just chaotically, but perform the most complex cosmic choreography. Doppler shift measurements show that some galaxies are approaching us at 5,700 kilometers per second, while others are moving away at 6,600 kilometers per second. The speed difference between the members of the group reaches almost 1,000 kilometers per second, which is 3,000 times faster than the speed of sound in the air. At such relative speeds, collisions become especially destructive. But the most surprising discovery in recent years is the discovery that Stephan's sextet is surrounded by a giant halo of dark matter. This invisible substance, which does not emit light or interact with ordinary matter, makes up about 85% of the group's total mass. It is its gravitational pull that holds galaxies together and determines the trajectories of their dance of death. Without dark matter, galaxies would have long ago scattered in different directions. Observations in the radio range revealed another stunning detail. Huge clouds of neutral hydrogen, the most abundant element in the universe, stretch between the galaxies. These clouds contain the mass equivalent of billions of suns and are the building blocks from which new generations of stars can be born. Some of these clouds are shaped like long filaments or bridges that connect galaxies, as if the cosmos itself is trying to stitch together a system that is tearing apart. Now imagine that somewhere in one of these galaxies, on a planet orbiting an ordinary star, there could be a civilization looking up at its night sky. What would they see? Not the faint dots of distant galaxies, as we see, but a colossal cosmic representation unfolding directly overhead. 4 giant galaxies, each the size of the full moon in our sky, would hang in their skies, glowing with billions of stars. They would see tidal tails stretching across half of the sky, regions of young blue stars shining like cosmic diamonds, and dark dust clouds where light is absorbed and new suns are born. But their night would never be truly dark. An intergalactic medium filled with billions of exiled stars would create a faint, ghostly glow across the sky, a constant reminder of the cosmic catastrophe unfolding around their world. Astronomers of this civilization could observe how the structures of galaxies change markedly during their lifetime. What for us requires millions of years of observations, for them would happen before the eyes of one generation. And here's the paradox. Despite the seeming chaos, mathematical models show that systems like Stephan's sextet are crucial laboratories for cosmic evolution. It is in such groups that the massive elliptical galaxies that we see in the modern universe are formed. It is here that the gas is processed, enriched with heavy elements, and the conditions for new star formation are created. Moreover, recent studies show that similar compact groups of galaxies were much more common in the early universe, billions of years ago, when the cosmos was smaller and denser. Stephan's sextet is a kind of time machine, a window into the turbulent past of the universe, when galactic collisions were not the exception, but the rule. The James Webb Telescope has discovered something completely unexpected in the system. Tens of thousands of globular clusters, dense groups of old stars, each containing hundreds of thousands of luminaries. These clusters were born during previous waves of collisions, some of which may be older than 10 billion years. They have survived many cataclysms and continue to exist, drifting in the chaos of intergalactic space, living witnesses to the group's ancient history. Even more intriguing is the discovery that the rate of collisions and interactions in the sextet is not constant. The system goes through cycles of activity. Periods of intense collisions are replaced by relatively calm phases, when galaxies move apart to then approach each other again. We may be witnessing one of the peaks of activity, the moment when the cosmic drama reaches its climax. Infrared observations have also revealed huge amounts of organic molecules in sextet's dust clouds. Polycyclic aromatic hydrocarbons, the very compounds that are the building blocks for more complex organic chemistry. This raises an exciting question. Could such extreme environments, despite all the chaos, be places where the conditions are created for life to arise? And here we come to the most philosophical aspect, to the realization that destruction and creation in space are not opposites, but two sides of the same process. Stephan's sextet teaches us the fundamental law of the universe. Nothing is eternal, but nothing disappears without a trace. The galaxies we see today will be destroyed, but something new will be born from their remains. More massive, more complex, enriched with elements created in the cores of billions of stars. Every atom of iron in your blood, every atom of calcium in your bones, every atom of carbon in your cells was created in similar cosmic cataclysms billions of years ago. We are literally made up of stellar ash, born in the collisions of ancient galaxies. Looking at Stephan's sextet, we are looking at the process that created the conditions for our own existence. The distance of 290 million light-years means that the light we see today left these galaxies when the age of dinosaurs was just beginning on Earth. The events we are witnessing now, collisions, supernova explosions, the birth of stars, took place at a time when giant reptiles roamed our planet. And what is happening there now? At this very moment, we will know only in 290 million years, when humanity may no longer exist. This time delay creates a strange feeling. We are observing the past, but for those galaxies, it is their present. We are studying events that have long ended, but the effects of which continue to spread through space and time, reaching us only now in the form of ancient light. Modern astronomers use Stephan's sextet as a kind of Rosetta Stone to understand galactic evolution. Every wave of radiation, from radio waves to gamma rays, tells a different part of the story. X-rays show us hot gas and active black holes. Infrared light penetrates the dust clouds, revealing hidden regions of star formation. Ultraviolet light indicates young, hot stars. By putting these pieces together, we get a complete picture of one of the most complex and dynamic processes in the universe. But even with all our technology, mysteries remain. For example, why do some compact groups merge quickly in a few 100 million years, while others remain relatively stable for billions of years? What role does dark matter play in this dance? And the most intriguing question is, are there even more extreme systems in the universe where not 5, but 10 or even 20 galaxies collide at the same time? Observations in recent years hint that Stephan's sextet may be part of an even larger structure, a filament of dark matter stretching for tens of millions of light years. These cosmic filaments form a kind of skeleton of the universe, along which galaxies are grouped. If so, then what we are observing is not an isolated event, but just one node in the vast cosmic web. The web that binds together the entire observable universe into a single, ever-evolving system. Cosmologists call this structure the vast cosmic web. Galaxies are not scattered randomly throughout the universe. They follow invisible filaments of dark matter, gathering in nodes to form clusters and superclusters. Stephan's sextet is located in one of these nodes, where the density of matter is higher and gravitational interactions are stronger. This explains why collisions are inevitable here. Galaxies are caught in a gravitational trap from which there is no escape. Recent studies using gravitational lensing, the bending of light by massive objects, have made it possible to weigh the entire system. It turned out that visible matter makes up less than 15% of the total mass of the group. The rest is dark matter and possibly dark energy, the mysterious force that causes the universe to expand at an accelerating rate. Paradoxically, it is in such catastrophic environments that the most favorable conditions are created for the formation of planetary systems of a new generation. The gas, enriched in heavy elements from exploded supernovae, contains everything needed to form rocky Earth-like planets. Intense star formation means that millions of new solar systems are being born. Billions of years from now, as the chaos subsides and a new galaxy forms, some of these planets could become home to life. There is even a hypothesis that our own Milky Way experienced similar catastrophic collisions in my youth billions of years ago, and we are the descendants of that ancient cosmic drama. Astronomers have discovered stellar streams in our galaxy, long chains of stars that are the remnants of smaller galaxies swallowed up by the Milky Way. What's more, right now, our galaxy is slowly devouring the Sagittarius dwarf galaxy, and in 4 billion years, we're in for a huge collision with the Andromeda galaxy. We are not just observers of space disasters. We are participants in this eternal process. Stephan's sextet shows us our future. As the Milky Way and Andromeda begin to converge, our night sky will be transformed as dramatically as the sky of that hypothetical civilization in the sextet. The giant spiral galaxy will occupy a third of the sky. Its arms will be visible to the naked eye in detail. Star formation will flare up with renewed vigor. The sky will be illuminated by the light of millions of young blue stars. And in a few billion years, the two galaxies will merge into one. Astronomers have already come up with a name for it, Milkomeda. But there is also a deeper meaning in the study of Stephan's sextet. This system reminds us of the incredible scale of time and space. The processes we observe last longer than complex life exists on Earth. The distances are so vast that light takes hundreds of millions of years to travel through them. And yet we, tiny beings on a small planet, are able to understand these processes, measure them, predict their future, and realize our place in this grandiose picture. This is perhaps one of the greatest achievements of the human mind, the ability to look at a photon of light that has traveled 290 million years through the void of space and extract information from it about the temperature, chemical composition, velocity, and mass of the object that emitted it. Every spectral line, every shift in color, every flash of X-rays is a message from the distant past, and we have learned to read those messages. Stephan's sextet also poses existential questions to us. If galaxies, these giant cities of hundreds of billions of stars, are mortal if they collide, collapse, and are reborn, then what can we say about us? Our civilization has existed for several thousand years, our species for several 100,000 years, life on Earth for several billion. All this is a moment by cosmic standards, but this moment is filled with meaning, because it is at this moment that the universe becomes aware of itself through us. We are the way the cosmos explores the cosmos. Atoms assembled by stellar explosions have organized themselves into structures complex enough to understand their own history. When we look at Stephan's sextet, we don't just see distant galaxies. We see our ancestry written with light. And maybe somewhere out there in one of these galaxies, right now, in their present, though we won't know until 290 million years from now, other intelligent beings are pointing their telescopes in our direction of the universe and asking the same questions about meaning, time, and their place in space. This thought is both humbling and inspiring. We may not be alone in our quest to understand the universe. Perhaps there are thousands, millions of civilizations scattered across galaxies, each looking up at the starry sky and trying to solve the same mysteries. And if life could arise here, on our quiet planet in the calm arm of an ordinary spiral galaxy, then why wouldn't it arise there, in the turbulent star-forming regions of the Stephan sextet, where the building blocks for life, the heavy elements, are much more numerous? The SETI program, the search for extraterrestrial intelligence, sometimes points its radio telescopes at compact groups of galaxies, including Stephan's sextet. The logic is simple. Systems with intense star formation are more likely to produce planets and, therefore, life. Although it would take hundreds of millions of years for the signal to reach us, the very existence of such civilizations would change our understanding of life in the universe. Stephan's sextet also reminds us of the fragility and, at the same time, the stability of life. Despite cosmic catastrophes occurring on a galactic scale, stars continue to shine, planets continue to rotate, and somewhere out there, perhaps, life continues to exist and evolve, adapting to even the most extreme conditions the universe has to offer. Recent research shows that even during periods of intense collisions, there are relatively quiet zones in the sextet. refuges where star systems can remain stable for millions or even billions of years. Planets on the outskirts of galaxies, far from the centers of activity, could exist relatively normally, observing a cosmic storm from afar as we observe a thunderstorm from a safe distance. But there's a more intriguing possibility. What if civilizations in such active zones evolve very differently than we do? Living under the sky, where galactic collisions are visible to the naked eye, where new supernovae erupt every few years, where the very structure of the sky changes over the course of a single generation. Such civilizations would have understood the dynamic nature of the universe from the very beginning. Their philosophy, religion, and science would be imbued with the ideas of change, transformation, the eternal cycle of destruction and creation. We, living in a relatively quiet corner of a quiet galaxy, have believed for thousands of years that the stars are stationary and eternal. It is only in the last few centuries that we have begun to understand the true nature of the cosmos, its movement, its evolution, its restless energy. Stephan's sextet is a textbook written by the universe itself, a lesson that nothing stands still. Today, this lesson is especially relevant because we are living in a unique moment in cosmic history, a moment when we can observe these processes with unprecedented clarity. Next-generation telescopes, which are planned to be launched in the coming decades, will be able to see Stephan's sextet in even greater detail. The extremely large telescope with its 39-meter mirror, the Nancy Grace Roman Space Telescope, which specializes in infrared radiation, will allow us to distinguish individual star clusters in the galaxies of the group. Trace gas flows in real time, more precisely, in slow time due to the vast distances, and perhaps even detect exoplanets in this turbulent system. Imagine, we could find a planet orbiting a star in Stephan's sextet, the planet from which you can see the most dramatic view in the entire known universe. A planet that exists on the verge of cosmic chaos, but still exists. This would be one of the greatest discoveries in the history of astronomy. Not just confirmation that planets can form under extreme conditions, but also proof of the incredible stability of planetary systems. Stephan's sextet also teaches us humility. Despite all our achievements, we are watching events that have already happened when there were no humans on Earth. There were no primates, as soon as the first mammals appeared. The real state of these galaxies remains an absolute mystery to us, and will remain so, until we invent ways to travel faster than light, or at least get information instantaneously, which, according to our current understanding of physics, is impossible. Einstein showed us that the speed of light is not just a speed limit. It is the fundamental structure of causality in the universe. Information cannot travel faster than light, which means that we are forever locked in the past of distant objects. The farther we look into space, the deeper we look back in time. Our most powerful telescopes see galaxies as they were billions of years ago, perhaps shortly after the Big Bang. Some of these galaxies no longer exist. They collided, merged, collapsed long ago, but their light still travels to us through the cosmic void. Stephan's sextet is located in a curious intermediate zone. It's far enough away to remind us of the vastness of the universe, but close enough that we can study it in detail. It's the perfect laboratory, not too ancient, not too far away, but demonstrating processes in their full complexity. Interestingly, such compact groups may play a key role in one of the greatest cosmological mysteries, the problem of missing baryonic matter. Computer models predict that there should be more ordinary matter, baryons, in the universe than we observe. Where is she? Recent studies hint that a significant part of it may be warm and hot intergalactic environments, namely in areas such as the space between the galaxies of Stephan's sextet. This matter is too hot to form stars and too thin to be easily detected, but it's there, huge clouds of ionized gas with temperatures of hundreds of thousands and millions of degrees, glowing in X-rays and ultraviolet wavelengths. Galaxy collisions, such as those that occur in the sextet, eject gas from galaxies, heat it to extreme temperatures, and distribute it throughout intergalactic space. Perhaps the lion's share of the missing matter of the universe is located in such systems, hidden from our eyes, but playing a critical role in cosmic evolution. This opens up another dizzying prospect. The space between galaxies is not empty. It is filled with matter, energy, magnetic fields, cosmic rays. It is an active, dynamic environment. For a long time, we thought of the cosmos as a void with rare islands of matter, galaxies. But it turns out that the opposite is true. The entire universe is one huge ocean of matter and energy, where galaxies are only denser nodes in an infinite network. Stephan's sextet shows us this ocean in action. Shock waves propagate through it like ripples on water. Magnetic fields twist and intertwine. Cosmic rays, particles accelerated to near the speed of light, penetrate space in all directions, creating an invisible web of energy that connects everything into a single system. These cosmic rays carry another amazing story. When scientists analyze cosmic rays that reach Earth, they find traces of events that occurred in distant galaxies millions of years ago. Some of these particles may have originated in supernovae or near black holes in systems like Stephan's sextet, traveled through intergalactic space for tens or hundreds of millions of years, and eventually collided with a detector in a laboratory somewhere on Earth. Each such particle is a messenger from distant worlds. Physical evidence of cosmic catastrophes. The magnetic fields in Stephan's sextet are also a mystery. Radio observations show that the entire system is riddled with ordered magnetic structures that stretch for hundreds of thousands of light years. How are these fields generated and maintained under conditions of chaos? One theory suggests that the turbulence created by collisions works like a giant cosmic dynamo, constantly amplifying and reorganizing magnetic fields. These fields, in turn, affect the motion of charged particles, the formation of stars, and even the trajectories of gas flows. Everything in the sextet is interconnected. Gravity, magnetism, gas pressure, radiation, dark matter, all play a role in the cosmic ballet. And what is surprising, we are only just beginning to understand the depth of these relationships. Stephan's sextet is not just a beautiful picture in an astronomy textbook. It's a living laboratory where the universe demonstrates its most fundamental laws in action. Here we see how gravity works on a galactic scale, how matter and energy transform into each other, how order is born from chaos, and creation is born from destruction. Each new picture, each new observation reveals details that we did not notice before. Perhaps in 10 or 20 years, we will find something completely unexpected in this system, a phenomenon that will force us to rewrite physics textbooks. The history of science is full of such moments when a detailed study of one object led to revolutionary discoveries. In the meantime, Stephan's sextet continues its slow dance of destruction and rebirth, indifferent to our observations, subject only to the laws of physics and time. In 1 billion years, the 5 galaxies will merge into one, creating a new cosmic island, a massive elliptical galaxy that will exist for trillions of years until the universe itself changes beyond recognition. But now, at this moment in cosmic history, we have the privilege of witnessing one of the most grandiose spectacles of the universe. And it reminds us that we are part of something incredibly big, ancient, and beautiful. Every time we look at a photo of Stephan's sextet, we're not just looking at distant galaxies. We're looking into a mirror of cosmic evolution that shows us where we've come from and where we're going. After all, we are all children of the stars, born in cosmic catastrophes, watching cosmic catastrophes, trying to understand our place in this endless cycle of transformation. And in this desire to understand, in this desire to look beyond the horizon of the known, is the whole essence of what makes us human. Stephan's sextet awaits you 290 million light years away in the constellation Pegasus, continuing its eternal dance among the stars.